This production is brought to you by the University of Edinburgh.
Hello, and welcome to an interactive introduction to MATLAB. This screencast will look at basic curve fitting in MATLAB. Once you have imported or input some data into MATLAB, you might want to find a line of best fit for your data. MATLAB has many powerful curve fitting options, but in this session we will only look at the basic fitting options found in the figure window. Firstly, we will import our experimental data into MATLAB. In my current directory window, I have some data I have saved called quad_fit_data. Double-clicking on this file opens two variables in the workspace, x and y. Moving back to the command window, I will plot these two variables. Before any fitting, we will annotate the plot and prepare the data. Turning on the interactive tools, we will select the data, remove the line, and add plot markers so we can view the discrete data points. We'll also give the data a name, and we'll label up the axes, simply x-axis and y-axis. Now we are ready to do some curve fitting, which we can find in the Tools menu under the Basic Fitting option. It is a fairly self-explanatory option. First, we need to make sure we have the correct data set selected. Next, there is a list of different fits we can try. Looking at the data, it looks like it most likely will be a quadratic fit, so we can try that one first. We can also turn on the equation for the fit, and this is displayed in the figure window. There is also another option called plot residuals. A residual is the difference between one of the discrete data points and the corresponding value on the fitted curve. Ideally, we would like to minimize the residuals to achieve a good fit. The residuals should also be randomly distributed with a zero mean, which is the case for this example. Returning to the basic fitting and choosing a fit which is not as suitable, for example a linear fit, you can see that it does not fit the data very well. This is reflected in the much higher residuals and the fact that they are no longer randomly distributed and don't have a zero mean. Returning to the quadratic fit and turning off plot residuals, we will finish this screencast by annotating the plot slightly more to allow the curve to stand out. We can also change its name by double-clicking on its legend. Once you have turned off the interactive plotting tools, we are now ready to save the plot.
This production is copyright the University of Edinburgh.